Okay, this continues section 3.3. We're continuing on with our example of finding the slopes of lines using the slope formula. So we have the 2 points, 3, 0, and 3, negative 1/2 that are on our line. So we're going to go ahead and find the slope. So m is equal to y2, negative 1/2, I'll call this, minus y1, we'll call that 0, over x2, 3, minus x1, which is 3. And so now we're going to simplify this. Negative 1/2 minus 0 is a negative 1/2, and 3 minus 3 is 0. And we know that anything divided by 0 is undefined. And so what we see is that we have an undefined slope. Well, undefined slopes are special. Undefined slopes come from lines that are vertical. Remember from the last section we talked about lines that had ordered pairs with all the same x's in them, and those were vertical lines. And so that's what we saw here. Look at this. The x's are exactly the same. We're going to come back to this one more time at the end of the section when we see a visual representation of this. And we're going to come across the fact that we have a very interwoven set of conditions that we learned about in that table of values there, that table that I explained to you in the last section about vertical and horizontal lines. And we are seeing that the slope of a vertical line is indeed undefined, because when we know that the x's are exactly the same, we know we're talking about a vertical line. All right, now we're going to go on and we're going to do our next example here. So again, we're just going to jump right into the slope formula. And so we see y2 minus, and then I'm going to use some parentheses, y1, negative 9 again, and then over x2, 1/2, minus y2, x1, sorry, x2 and x1, 1/3. And again, just notice, right? 1/2, negative 9, that's an ordered pair. 1/3, negative 9, that's an ordered pair. It's always a good check for you guys to do. So negative 1 minus a negative 9 is a negative 9 plus 9, which is 0. And then over, and we have this fraction problem here. So we have 1/2 minus a 1/3. And so I'm going to build the higher terms on those really quickly. LCD is 6. And so I'm going to build the higher terms to 6. So 2 times 3 gives me 6. So 3 times 1 gives me 3. And 3 times 2 gives me 6. So 2 times 1 gives me 2. And 6 minus 2, 6 gives me 1/6. And so my denominator here looks like 1/6. Now, not that that really mattered, because 0 divided by anything is equal to 0. And we see that line has a slope of 0. That's another special type of line. Remember that the slope of a horizontal line is 0. And what we see here is two y's that are exactly the same. And in the last section, again, we learned that the lines with the same y coordinates every time are indeed horizontal lines. And so what we're seeing via the slope formula here is that this is a horizontal line. It has 0 slope. All horizontal lines will have 0 slope. All right, now I'm going to pause and let you guys do example number 9 there. And I think you probably should pause the video and just go ahead and do that example for yourself. In this example, you're going to see some simplifying going on, and we're going to reduce that down. So I'll pause and you can go ahead and calculate that on your own. Okay, hopefully you've gone ahead and you've worked this on your own. So I'm just going to briefly go through it. So you should have done 1 minus 15 over negative 3 minus 7, or vice versa. Remember, that's just going to change the signs, not the numbers. So I got a negative 14 over a negative 10. Now a negative over a negative is the same as a positive. That must be simplified. But the other thing that we need to realize is that this needs to be a true ratio. Remember, ratios are in lowest forms. So these are both even. So we're going to take out that common factor of 2, which gives us a slope of 7/5. Slopes must always be simplified. Remember, simplified does not in this case mean that it's a mixed number. Remember that slopes are always a ratio. The only time that we write it in a way that it doesn't look like a ratio is when it's a whole number, and you've seen plenty of those in the last couple of examples. All right, now we're ready to learn about a couple of different things in a visual approach.